Hey guys, I got another update for you on the wiring harness. So made quite a bit of progress since the last video. I've almost got all the wiring figured out for this to plug straight into my existing Mirage harnesses and just work, which is pretty cool. So let's see. So I've started. I ordered some of this Painless Performance Power Braid. Really like how this stuff looks. It looks a heck of a lot better than the convoluted tubing that they use from the factory. And I've got a lot of the harness finished here, so I'll go ahead and show you guys that a little bit. So here's what it looks like when it's installed. It's got a really high-end look and feel, which is what I wanted to go for. Not planning on having to do anything else to the wiring on this car ever, so hopefully that will be the case. I had to, let's see here. I had to change a bunch of stuff up on the harness as far as connectors and what they're used for. Obviously, I don't have the emissions equipment like EGR and stuff on my car because it's got a JDM engine in it. So I was able to repurpose some of that wiring for other things that the Evo needs, and ended up not having to add a single wire to this harness. Just able to repurpose existing wires, which is awesome. So let's start down here. Let's see. This is one of the coil packs. This is the crank angle sensor. This harness had a different connector for the crank angle sensor. It actually had one of these connectors for it, which is really strange. So I chopped that off. You stagger your cuts when you're doing something like this, and if you stagger your cuts, you're able to put splices in, and they won't overlap each other, which makes the wiring a lot neater, and you can't even tell that I had to splice wiring in here, which is nice. So, or in this one, yeah, see, I can't even tell. So I really like how that's come out. This on the Mirage, for whatever reason, is the rear O2 sensor. This is where the front O2 sensor is on the Evo. So, this being a 4-wire O2 sensor, the heaters circuits are the same across both of them. That's the same wiring. It has continuity between them, so that means that they both get the power and ground for the heater circuits from the same place, so I didn't have to do anything with that. And the ground is shared as well, or power, I can't remember. So all I had to do to change this from a rear to a front O2 sensor was move the pin on I think it was this connector. Pretty sure it was these two white wires. I verify all that stuff with wiring pinouts. So if we look here at this wiring pinout, where are we looking here? So there's lambda. Where's the rear? It is. Did I just miss it? Oh, you know why? That's because that's the Evo 4. So there you go. Pin 75 and 76 is front and rear O2 sensor signals. So that's this connector, 5th and 6th pin over. So there you go. You'll notice the 6th pin over is not actually there. I moved it to the 7th pin over. And the reason for that is, hang on, or I'm sorry, 8th pin over, right? Fourth one from the right. Yeah. So if we look here, that's pin 78. Pin 78 is the knock sensor. So this harness, the Mirage didn't have a knock sensor on it. It had what's called an ignition misfire sensor, and it's not even close to the same plug, so I ended up just removing that from the harness and capping the wires off. So heat shrunk and then electrical taped them just to keep them sealed. So the original rear O2 sensor, right here, I kept the heater circuit wiring just so I can add a rear O2 back if I ever want to. But the ground is just a sensor ground, and then this wire I moved over for the NOx sensor, and then I just unpinned these two wires here and then pinned them into this connector here, which is what the NOx sensor plugs into, and boom, instant NOx sensor wiring added. So that was really simple. And then I took an old O2 sensor and scavenged the connector from it, and I'm going to fill the holes in with RTV or epoxy or something to waterproof it. That way no corrosion will get into this connector from leaving it open. So that is that. Moving on, let's see, throw that back in the pile of stuff here. So moving on, we've got our injector connectors here. Again, these are Nip and Denso injector connectors. I was able to order plug-and-play adapters for my Bosch EV6 injectors. Those should be here in a couple of days. This would have been for the purge solenoid. I do still have that, and then it's the same one on the Evo, so I decided to leave that wiring in. I'll plug it in. I don't think it'll do anything, but it'll be there. This is for the factory map sensor. So apparently the later model Mirages had a map sensor on the intake manifold just like the Evo. This is the same pinout. So before, because the Evo 4 doesn't have a map sensor, I had run the map wiring. I just used the barometer wire from the mass airflow, pinned that in where the map pin went, and then I used a spooling up Mr. Fred speed density harness. And here's my intake air temperature sensor, and here's my connector for my AEM 3.5 bar map. So I'll still use that for the intake air temperature sensor, but since the map wiring is already here and I can use all the factory wiring and not mess with that, I'm going to go ahead and use this factory connector. So that's nice. That simplifies my wiring a lot. Last injector. And then again, this is the NOx sensor now. We have the other coil pack wire. This is a noise suppressor that goes in for the injectors. The Mirage only has one of these. The Evo had two, but I kind of don't really think it's necessary to have two. Some people, I think, even remove these, so I'm just going to stick with the one. Let's see. This is the water temp sensor for the ECU. This one here, the single pin, is the water temp sensor for the dummy gauge. I don't know why they thought these cars needed two water temperature sensors, but that's just the way they did it. And we've got cam angle sensor here. Over here, we've got, let's see, what is this? This would be TPS sensor, or TPS sensor, throttle position. This is the idle air control valve. So I forgot I actually have to change this plug. The Evo 8 uses a newer style. This is the old style. Since I'm running an Evo 8 throttle body, I need to update to the Evo 8 style connector. Really easy to find. All 3rd gen Eclipses use the same idle air control valve. Mitsubishi has a different part number for it, but it's actually the same part. They want $250 or something crazy for the Evo one. I just go out to the pull yard, $10. I got an Eclipse one. It works fine. So I got to run out to the pull yard and snag one of these pigtails. I would just use the one from this other harness here, my Evo harness, but the right here, there's not very much wiring to these pigtails. You can see I couldn't even do a real clean job when I did this. I'm going to try to cut it off back here next time so that I get at least this much wiring and I can stagger the install, just because I'm trying to do a nicer job with this harness than I did with the Evo one. So that's the plan for that. And then once that plug is changed, then I can loom all of this in, because the rest of these are already done. So This is, I believe, this is one of the transmission plugs. I think it's for, you know what, I think this is the speed sensor, the vehicle speed sensor. This is one of the two harness interconnectors that connects the engine harness, which is this one, to the accessory harness. This is one of the two connectors that I still need to go through and figure out. I did figure out that my old Mirage harness actually has the same connector. I'm not going to try to dig through that harness for it, but so I changed my Mirage over to the 6-pin. So I think all I have to do is just remove those two wires and set it back to the way it was, and it should be good. So that'll be an easy one. This is the reverse light sensor wire for the transmission. Okay, here's an interesting one. So this is now the wastegate solenoid wire for my 3-port boost controller. So originally this would have been the wiring for the EGR, and it would have been somewhere over in here. Because again, my car does not have EGR, having a JDM manifold, intake manifold that is. I was able to repurpose this because it's the same connector for my wastegate solenoid, the 3-port boost controller. So all I did was unloomed it and pulled it all the way back to here through the harness, and then all the extra wiring I just kind of ran back and forth. Now you wouldn't want to do this if it was a sensor wire, because when you do this, running this wire back and forth like this, it creates resistance. But these are either on or they're off. There's no signal that runs through this. It's just powered or not powered. So you can get away with it in this case, but I wouldn't do that normally. I'd actually shorten it. But the less that I have to cut this harness, the better off it'll be. So I just went ahead and ran it back and forth and gave it about that much length. I think it's got about half this much length on the actual Evo harness. I just wanted to give it a little bit of extra. Mass airflow sensor here. I don't have that anymore, but again, we still use this for the speed density harness. So that's done. And then here's the big one. So my Mirage had an 8-pin connector here. This had a 10-pin. And I did figure out that this is a 2001 Mirage 1.8 5-speed harness specifically. So I've never actually seen a 10-pin connector here before, but that's what we got. So there's only one not populated port on this. I think my 8-pin has one not populated as well, so that means there's 2 extra wires in here that I need to figure out. But I think overall that won't be that big of a deal. So, and then once all that's figured out, I can go ahead and finish looming all this stuff in, make the rest of these look really nice, just like I did over here. So you can see that this is all loomed and done, and I'm pretty happy with how that looks. That looks really good. So anyway, so that's the update on that. Over here, like I said in the other video, the plan is to cut right here. This is where the stock firewall pass-through is, which is this thing here. I'm getting rid of this, and I'm going to put a Canon plug on the firewall, maybe 2 if I have to. I'm hoping I can get 100-pin Canon plug, but I may have to get 2 61-pin ones because that's what's available, at least for a good price. So I'll cut right here and then put all these on a Canon plug, and then that way I can just disconnect these from the firewall if I need to pull the engine. This stuff runs through the firewall, and then you've got a ground that bolts to the firewall behind the dash. So rather than just unplugging these couple of things and leaving all of the wiring harness on the engine, no, that's too easy. Mitsubishi wasn't going to allow that. So you actually have to either remove all of this wiring from the engine, which is a huge mess, or you have to pull your dash out just so you can get to that one connector, which is neat. But that's the way they built it. So they designed it wrong. I'm going to fix it. Now, some of you guys expressed interest in the tools that I use for all of this. So I figured I'd run you guys through how this stuff works, or what stuff I use for all this wiring. There's really not that much. So I use, let's see. So probably the most used stuff that I have here, close this door, is a pair of Grainly wire strippers. Apologize for the focus. The light's not real great in here. This is just your typical, I think I got these at like Lowe's. Grainly's a really good brand for these. They're insulated. And a pair of channel lock crimpers. So, and these are my favorite crimpers that I've used so far. Both of these I bought when I was doing HVAC work, and they still stay with my HVAC toolkit. I still do that stuff occasionally. I just don't do it for a company anymore. So these are really, really nice. So if you take a splice, and hopefully, I guess I shouldn't assume that you guys know what these are. This is the proper way to connect wires in a wiring harness. So this is just a heat shrink splice. Come on, focus. Well, that's about as good as it's going to get. Well, this is a heat shrink splice. So what you do is you strip the wire back that you're wanting to connect. If you've got a broken wire, take your crimpers here. I'm going to do this off camera here so I can get it. Slide the wire in there, and then squeeze this down, and it'll smash the tubing in. You can see how that puts a kind of a smash into this crimp, and that creates a actual, physical connection for the wiring harness. So a lot of people will say use solder. I don't recommend solder just because the heat and vibrations in the engine bay can cause that joint to fail. The factory actually uses crimps everywhere in their harnesses. So every single one of these connectors here, every single one of these pins inside these connectors is crimped. That's just the way they work. As long as you use quality crimps, which these are auto parts store ones. I usually buy 3M ones in bulk. I just didn't have any on hand, so this is what I used. And these may be... No, these aren't 3Ms. But, so you use these, and then the concern with using crimps generally is, well, you're going to get corrosion. Well, if you heat the ends of these up, you can see there's a long section on each side. Man, I cannot get this camera to focus. But anyway, if you heat these up, then they'll actually shrink like a heat shrink tube. And that's another thing that I use a lot is heat shrink on these harnesses. So you can buy these at any auto parts store pretty much. All it is little tubes. You can take one of these, put this on a connector, a crimp, whatever, and then heat them up with a heat gun, or if you're good, you can use a lighter, which is what I've been doing. And if you're really good, you can keep from burning the wiring, because that is something that's real easy to do. And when I was first starting out, I did a fair bit of wire burning. So if you can bubble this insulation and then create a leak. So you got to try not to do that. I actually haven't burned any of the wires in this harness, which is awesome. So try to keep it that way. And then again, I've been using this Painless Performance power braid. So for that, I've got some extra here. Well, here, I've got a short piece here. You cut a section and then put it over the wiring harness. It's split, so tape it up. When you cut this, though, it starts to fray. Just like rope, if you burn the ends of it, it will not fray. So that's another use for the lighter, which is nice. And then, of course, electrical tape. Lots and lots of electrical tape when you're doing wiring work. You tape the ends of it up just to keep things, keep these things from looking crappy or from trying to unravel on you. It just kind of makes everything a little nicer looking. These are just a little pair of hobby trimmers. I use these for cutting off old convoluted tubing or some of the heat shrink jacket. Like this stuff here gets real hard, and if you bend it, it will crack just from age. So those are really nice for cutting that off. Pliers, just regular pliers for removing special connectors like this. These ends here fold over. I'm trying to get this to focus here. So if you look, you can see there's tabs on either end of this, and when this is smashed down, those fold up and hold it together. So you just bend those back with a pair of pliers, and that will have you good. A couple other things here. I use these. These are called prods. There's tons of different types of them available. And these are really nice for unpinning and repinning connectors. Let's see here. So we'll use this as an example. There's no wires in it, but you see that orange tab in there? Most of these connectors will have some kind of mechanism that holds them together. I don't know if I can do, I don't think I can do this one-handed, but for this case, you'll see there's a hole through there, so you can pop that out. I did it. This is the retaining clip that holds the wires in, and then once you get that out, that holds the wires in, there are tabs that you can fold back. I don't know if you can see that or not, but that's how you release the wires from the connectors. And pretty much every connector uses some variant of that. For instance, the ECU pins, they have this little white connector. You can pop that out like this one, and then the release clips are down inside. You can kind of see them. They're in the bigger, so the smaller holes here are where the pins actually go. The larger holes have the release clips, so you can pry those back and then pull the wire out the back. And again, you know, pretty much every connector uses that in some way or another. The orange pieces pop out, and they've got clips similar to that O2 sensor one. You know, if you look at them, you can figure it out. Nobody really taught me that stuff. It was just, you know, stuff that I figured out on my own by looking at it. And you know, it's really not that difficult. Everybody says wiring's really, really hard. It's actually extremely simple. So this brings me to my last couple of tools. So when you're using Canon plugs or Deutsch connectors, any type of actual Canon plug, which is the round aircraft ones that have tons of pins in them, you don't just use a regular crimper on those. You have to use special crimpers. You use different crimpers depending on what type of plug you're doing. In this case, the ones that I'm doing have 4 crimps around them that are really, really strong, that hold the wire into the barrel connector. And if you look at this crimper here, if I squeeze the handle, let's see, yeah, there you go. You can see that this puts 4 crimps in. And this actually, I took the cap off the end of this, but it actually sets the depth. You can set the depth with the cap on there that screws on. So that's how you crimp the type of pins that I'll be using, is with something like this. These are aircraft grade. This one's not an aircraft grade tool. There are better tools than this, but this was like a $30 crimper compared to the actual aircraft ones, which are like $200, $300, $400, $500 sometimes. And there's the part number for these. And again, you notice that says AWG 12 to 20. That's the wire size. Generally, at least is the case for Mitsubishis and Subarus, most of the wiring is all 18 gauge or 18 AWG, and that's what this is. There's some bigger stuff in here, but for the most part, that's what you're going to be seeing. I don't know if I can find you a bigger one here. Yeah, there's a slightly bigger one. That ground wire is a slightly different gauge. You can see it's a little bit bigger. That's probably like 16 or 14 gauge. And then some of the other ones have even bigger wires, but you'll see that stuff if you guys do any of this kind of work. The most important thing that you're going to use is going to be a multimeter. So when you're trying to figure out what wires do what, you can look at your pinouts, and that's going to be a really big tool that's going to help you a lot. But you really need to verify this stuff because these pinouts change depending on the year. For instance, I've got an Evo 4 and an Evo 8 pinout here. Because the Mirage is closer to an Evo 4, 5, and 6. They share very similar pinouts. The Evo 8 is much different. I'm using an Evo 8 ECU, so I need to change a lot of my stuff over to this. So if we look here, for instance, pin 8, these look really similar. But if we look at pin 8 here is a fuel pump relay, pin 22, AC compressor relay. Well, if we look over here, pin 8 is the AC compressor relay, and pin 22 is the fuel pump relay. So if you don't flip those two wires in your ECU pinout, your car's not going to start. That's one of the things that's well known that you have to do to change over to an Evo 8 ECU is flip-flop those two wires. But there's all kinds of differences here. You can see I've gone through and marked all the differences between the harnesses here, and I've actually gone through and made a list of all the stuff that I needed to do, and I've almost got all of this stuff finished. I haven't checked it all off, but it's getting close. So wiring pinouts, these I just Google searched these, and you can find these printouts pretty easily. They're also on mirageforums.net for those of you who are on there. You can get them from Mirage 1, which is the site owner and moderator. So anyway, so say you've got a connector over here, and you've got a wire that you need to trace over here to verify it's correct. So the really important thing here is to have a multimeter that can do at least two things if you're going to be doing this kind of work. This is a really crappy meter. I've got a nicer field piece one that I use for working on heating and air stuff, but all I need is this one for this type of work. So I've set this to continuity on here, and you can see if I take these two leads and touch them together, I'm going to get a resistance readout here. Now this is kind of a crappy meter, so we've got just a little bit of resistance. If I can hold them together right there, okay, no resistance, boom. So, and this is ohms, so really anything less than 10 ohms is really good for an old harness. Most of the wiring in this harness is 1 ohm to 0 ohms, and that is really ideal. So what you would do is you would take one end of this and stick it in the ECU pinout over there, and the other end, it doesn't really matter which one in this case. Normally this would be your ground and this would be your power reading, but for reading continuity or resistance, it's not really a big deal. So one of these would go into the connector over here, the other would go into there, and boom, then you got your resistance readout. Other things that are useful, these are made by Fluke. They're not compatible with this meter, but I still use them just because they achieve what I need them to. These are for sticking into really tight connectors. Like if you can't get meter in, you can take, and these are designed to probe really fine connectors. So you can see I've got that in there, and then I'd be able to read that way. In this case, because these aren't compatible with the meter I'm using, I just stick that in, and then I'll take one of these little alligator clip wire connectors. Clip it on there, clip the other end to the meter probe, and boom, done. So that's more or less it, really. There's not much else to this. You just want to check your resistances, make sure you don't have too high of ohms reading on any of the wiring that you're using. And if you do have an ohms reading, make sure that there's not a resistor in line. Some vehicles have resistors in their wiring, like for instance the Evo has fuel pump resistors and an injector resistor pack. I think I talked about that a little bit before. So you'll get resistance readings on that, obviously, if there's a resistor in line. But really, that's about all there is to it. I mean, it's really simple to do all this stuff. It's just really, really tedious and time-consuming. I've been working on this for 4 or 5 days, and this is all the farther that I've gotten. You know, granted, I still have my regular job to do in the meantime, which takes a lot of my time up. So I really only work on this for a couple hours every day, but I mean, it's really getting there. Like, there's not too much left to do. Just have to change a couple of pinouts, get my cannon plugs done, and I think it'll be ready to install. So I haven't ordered the cannon plugs yet. I'll probably do that soon, but I would say within the next 2 weeks, this thing should be ready to reinstall in the car. So anyway, hopefully that's a good update for you guys. Again, I just kind of wanted to walk you through the tools I'm using. I had some people ask me how I did all this stuff, what tools I need that they need to do the same kind of work. This is just the stuff I use. There's all kinds of other options out there. So just try different things and use what works best for you. Oh, and there's one other thing. Highly recommend getting one of these. So the AEM makes this. This is an ECU patch harness. If you get one of these, you can change your pinouts on this instead of having to rewire your harness all the time. And that way you can keep your harness original, and you can just chop wires on this, or whatever you need to do repinning wise can be done on this, so you can leave your harness original. Now I've changed a couple of things on this harness because I know that they're never going to be switched again, but for the most part all of my rewiring is done on that. So anyway, like I said, that's about all I've got for you guys right now. I'll give you guys another update here in probably another week or two. I don't anticipate getting a whole lot more done on it besides changing this connector out over here for the idle air control valve, and changing the 4-pin and the 10-pin connectors to match my existing harnesses. But I would say expect an update once the cannon plugs are done, so probably another week or two, and you'll be hearing from me again. Anyway, that's all I got for you guys for now. Hopefully